Once you've discovered that your code doesn't do what you wanted it to, you now want to do three things. You want to isolate the bug, or bugs, because there's probably more than one. You want to get rid of them. And then, as I said earlier, you want to go back and retest, and keep doing that until you're sure that the code actually runs correctly. That last point is important because all too often you spot a bug, fix it, and think, I'm set, and not realize that there's another bug hidden that you didn't get to. So do all three of these stages as you do that. Now, the word bug, odd word. Where does it come from? Well, I want to tell you a little story, and I want to go back to September 9th of 1947. One of the earliest machines, one of the earliest computers built was something at Harvard called the Mark II Aiken relay computer. And I'm sure you've heard stories like this, but this was something that filled an entire room. It was built out of vacuum tubes and electronic relays and other very large-scale electronic components. It didn't do a lot. Obviously, we've come a long way, but it was one of the earliest computers. One of the key people in the design and programming of that computer was a woman named Grace Murray Hopper, a very famous computer scientist who eventually retired as an admiral in the U.S. Navy. And shown on the left here, along with her colleagues, doing some programming on one of the earliest computers. This console is actually not from the Aiken, it's from a different computer, but it gives you a sense of the kinds of things they did. As they were testing that system on that day, they started running some tests of the arithmetic functions in there. They started up an arctan test, and they were running it. They started up a cosine test, and they were running it. And they kept getting an error. They kept getting something that wasn't working. They tried a bunch of things to debug it. They didn't use that word at the time, I don't think, but they tried a bunch of things to debug it. And finally, one of the technicians went back into the computer and unscrewed one of the vacuum tubes that was in there. And inside it, he found that a moth had flown into the computer and had shorted out the connection. And as you can see in Grace Hopper's words here, this is the first actual case of a bug being found. Whether this is the first use of the word bug or not, most of us in computer science love it because it gives you a sense of why we use that word bug. So that's where the word bug comes from. Now we're going to talk about where do bugs themselves come from. And here there are a couple of things that we want to distinguish between. First of all, there are overt bugs and there are covert bugs. Overt bugs mean that there's an obvious indication that something's wrong. The code crashes. It stops before it gets to an answer. Or worse yet, the code runs forever. It goes into an infinite loop, which you'll eventually decide when you get tired of waiting for the machine to stop and you stop it yourself. Those are obvious bugs, and you know you need to fix them. Covert bugs are ones where there's no obvious manifestation. The code actually returns a value, but it may not be the correct one. And these are sometimes harder to determine. That's where the test suite's going to be really important to try and capture. I've got something not behaving the way I expected. You don't want code to return values that appear to be legal values but are not in fact the expected values. Similarly, bugs can be both persistent and intermittent. Persistent ones are the easier ones. It happens every time. Every time I run my code, it crashes or it returns a particular value. I know I've got a problem, I can find it. Intermittent ones are those that occur only sometimes, even if run on the same input. And they tend to depend on other factors. Maybe dealing with something on the web, or maybe dealing with something where the time actually is an important factor. And as you might expect, finding overt and finding persistent bugs and removing them is pretty easy. Finding covert or finding intermittent ones takes more work and are often harder to spot and get rid of. So, what are ways we might deal with this? Overt and persistent, they're obvious to detect, and good programmers typically use defensive programming to try and ensure that if the error is made, the bug's going to fall into this category. In other words, steer it to this direction because it's going to be easier to find. We'll see some examples of defensive programming that can help with that. Overt and intermittent obviously are more frustrating. They're harder to debug. But if the conditions that prompt the bug can be reproduced, they can be handled. And that often is what you'll do here is, you know there's an overt error here. You just have to try and figure out what were exactly the right conditions to make sure that the bug reappears, and that'll allow you to isolate in where you want to go to try and find the bug and remove it. The latter category are the toughest ones. They're highly dangerous, as you as a programmer may not realize they're there, and more importantly, the user may not realize that answers are incorrect and until the code has been run for a very long period or has gotten to a very different portion of the code, and trying to backtrack to find where that error came from can be really hard. So this is where defensive programming can be important, because if you can force bugs into this category, you're just in better shape.